Assalamu alaikum warahmatullah. My name is Abdulaziz bin Hussein, and today I'm going to be doing the demo for my advanced digital logic design course, which is the FPGA-based real-time gesture recognition and communication system. The system consists of a flex sensor connected to a voltage divider and a comparator connected to a FPGA board with a built-in 16 times 2 LCD screen. So to verify that our system is fully functional, uh, just to clarify, when the hand is fully open, we consider it as is all zeros. When the hand is fully closed, we consider it as all ones. So if we go to a demonstration video we made in the lab with our system, we can recognize that when the first input of our thumb is closed, we get the answer as I am okay. And once we check our table, we have our thumb closed, we have I am okay as the output. Moving forward, when we have our index finger closed, we have our output as yes. Going back to our table, it verifies that. And as we move forward, you see our LCD text changing depending on our our inputs that we made in the code. So when we have our middle finger closed, we have the answer as no. Going back to the output, it says no when we have our middle finger closed. Moving forward, same with need help with for the ring finger. Same thing it says here in our table. And let's check the pinky. Same thing it says stop. There's a bit of fluctuation in our output because the sensors we have are actually pressure sensors, so a bit more sensitive than the flex sensors. That's one of the main issues we faced at the beginning of our hardware designs, that we got actual pressure sensors rather than flex sensors. That's why in some of our inputs we end up kind of, as you can see here in the video, when we press on it manually, we get the output we want. Let's go back a bit. As you can see here, when we press on it, we get the output that thank you. When we come here, you can see when we press on the thumb and index, we get the thank you. So once we press on the sensors, it works better, but also it works with bending. So overall, the implementation was correct, but then if we used actual flex sensors, it would have gave us better results. Alhamdulillah, our system was fully responsive and we were getting outputs exactly like how we wanted it to be on the screen. Next, when we go to the part where I was handling, so in this project, I was handling the circuits and about the hardware diagrams more specifically, going over each individual connections. We have the actually have the circuit here next to me, but then the connections are a bit all over the place and they're a bit complex to explain. So I'm going to explain them in Tinkercad. For the flex sensor, we're going to have one of them connected to the 5 volt and other leg connected to a resistor and then to the ground. So 10K resistor is connected the flex sensor to the ground, and that same resistor connected to the ground is going to connect our flex sensor to the third pin, which is the input 2, or it's written here input 1, into input 1 plus, but then in our comparator is written as pin 2, but anyways, it's the same concept. So here it's gonna input the uh, voltage coming from the flex sensor. So from the flex sensor to a resistor to the comparator, which is the third leg, which is here input 1 plus. Moving on to so this is going to be for all the flex sensors. There's going to be a constant connection for all the flex sensors. Next, for the voltage divider, we want to have a good reference voltage that's going to be set. Initially, we used the potentiometer, but then we found the easier method. So what we did was we connected in series, we connected the 22K resistor to another 22K resistor, and then we connected it to a parallel to a 10K resistor, and we got the midpoint connecting them. This is going to be alongside with the obviously 3.3 volt input coming from the FPGA board. We're going to get a reference voltage of 0.6, which is going to be given to all our comparators in the second pin. So pin 2 is going to be the reference coming from the voltage divider circuit, which is here, and it's going to be 0.6 voltage coming out of it. That's going to be for the input pins of the comparator. For the first pin of the comparator is going to be the output. It's going to be connected directly to our FPGA board. In here we have Arduino and LCD connected, kind of imitating FPGA board cycle 2 which we used. But then here we can see that it's connected from the output pin direct to it, and we have a 10K resistor connecting that same output pin to the ground, to the positive pin, sorry. So again, it's going to be connected to the power by 10K resistor, and it's going to be connected straight to the FPGA board. The last pin is going to be ground. Here is going to be the power pin connected straight to the power, and then these three pins are going to be imitating these three pins exactly. So it's going to be the output, second input, and the first input. This is going to be the reference. This is going to be from the coming from the flex sensor. This is going to be going to the FPGA board, and then get registered to the positive terminal. The main thing about this circuit was the voltage divider. As I said, initially we used the potentiometer, but then we found this method giving us 0.6, which is actually really optimal for our comparator. So this voltage divider is going to give us 0.6 to the comparator. And the comparator, what it's going to do is it's going to compare the input voltage from the flex sensor and check if it's greater than 0.6, it's going to be considering it as 1. If it's less, it's going to be considering it as 0. That's why we have a comparator. And that output is going to be given to the FPGA board, and the FPGA board is going to take all of these inputs, put it all together, and it's going to check its input table and check which output to be given to the LCD screen exactly. This project was the most challenging part of the project was first of all dealing with the GPIO pins in the FPGA board. It was new to us. Connecting an external circuit to the FPGA board was also a new challenge to us. Also, we had an issue with the flex sensors. As I said, we bought pressure sensor actually, which kind of had a negative impact on our outputs. As well, finding the correct reference voltage was an issue for us. We had to find the correct resistor connections and correct voltage divider connection to get the specific 0.6 volt. That was another issue for us. But alhamdulillah, this project actually taught us a lot of things. One of them being that we knew exactly now how to connect an external circuit to the FPGA board. We used to think that the FPGA board had limited use, and now this project can give us the idea that we can use the FPGA board for more and better projects, inshallah. And it really shows the power of the FPGA board. And regarding the flex sensors, it introduced us to the flex sensors and how to use it, and inshallah we'll be using it for more projects. Thank you so much, doctor, and thank you for listening. Inshallah, we'll see you in other courses. Assalamu alaikum.